So here we're going to talk about we're going to use a talk about a pre-trained tokenizer. So let's begin. Why we use a pre-trained tokenizer? So the core idea is building our own tokenizer from scratch can teach you how tokenization works, but in real world natural language processing, it's usually inefficient. Why? Because pre-trained tokenizers already trained on huge datasets, handle the reward better, automatically format text for specific models. It saves time and reduces errors. For example, instead of manually splitting the text, I love programming, you'd have to split words, or build vocabulary, assign IDs, and special tokens, or having a padding or truncate it. So the pre-trained tokenizer does all automatically. What is Hugging Face? So Hugging Face, originally a chatbot company, now one of the biggest AI or natural language processing ecosystems. Think of it like a GitHub-less app store for AI models. Um, it provides models like BERT, GPT, Roberts, and T5. So the tools is having tokenizers, datasets, and pipelines. So the common natural language processing task is text classification, translation, summarization, and question answering. So why Hugging Face is powerful? Instead of building tokenizer manually, um, training model from scratch like that, you can download pre-trained tokenizer, download pre-trained model, focus on solving our actual problem. So what is BERT? So the meaning of the BERT is it's B for the bidirectional, E for encoder, R is representations from transformers. So in short, bidirectional encoder representations transformers. So the key feature of it is bidirectional understanding. So BERT reads left context and right context. Example, the sentence "the bank is near the river." BERT understand bank means river bank. Sentence, I deposit money in the bank. BERT understand bank means financial institution. So why? Because it looks at both sides. So part 5 is BERT training data. So BERT was pre-trained on English Wikipedia book corpus. This gave a massive language understanding. So why BERT needs special formatting? BERT doesn't just accept raw sentences. It expect tokenized words or subwords, special tokens, IDs, padding, and truncation. So what is word piece tokenization? BERT uses word piece. So the purpose is to break rare words into known smaller parts. So the example is unhappiness may become un and happy and ness. Quite useful if BERT never saw unhappiness, it may still know unhappiness. This helps with unknown words. Next is special tokens, or when we add CLS added at the beginning. So the purpose of the CLS is represent the whole word sentence for classification task. Next is SEP, or added at the end. The purpose to mark sentence boundary. Example, when we input the I love NLP, so the beginning of it is CLS, or the added at the beginning, and next is I love NL and P and SEP at the end as a mark sentence boundary. Next is we import the tokenizer. Like we use the code from transformers, we import BERT tokenizer fast. Why fast? Because it optimizes and faster than regular tokenizer. Next is loading the pre-trained tokenizer. We use the BERT tokenizer fast that from pre-trained. We access the BERT base and case. So breakdown, the BERT base and case is BERT base is standard BERT model, and the case is lower case only. Example is hello will become all small hello. Case is ignore. So the tokenizing sentences, we have like example encoded is given a tokenizer, Inside of the sentence, the padding is equal to true, truncation is true, return is PT. Next is important parameters. So the padding is equal to true, makes all sequences same length. Example, sentence 1 is I love AI, sentence 2 I love artificial intelligence. Makes all sequences length. Without padding, lengths differ. Hard for tensors. With padding, shorter than gets pad. Truncation is a true. Cuts text if too long. BERT has many tokens, like usually 512. Return tensors equal to PT, returns PyTorch tensors. So the PT is equal to PyTorch. Next is output structure. Tokenizer returns their dictionary. Next is input IDs, numerical tokens. Example, hello means 7592. And we have the attention mask shows 1 is equivalent to real token, 0 is padding. Next is convert IDs back to tokens. So tokenizer that convert IDs to token. Encoded input and index is 0. Why it's useful to inspect word splitting, special tokens, padding. Next, vocabulary access. So tokenizer that get vocab. So the output is the equal 1996, the cat is 4937. Why vocabulary matters? Helps us to inspect token mappings, understand token IDs, debug natural language processing pipelines. So the full pipeline is from the raw text, like I love machine learning. It converts to the lower case, it tokenize and convert to the IDs or the numbers. We having a padding and truncate it for equal length for batches. We return PyTorch tensors. Ready for a model. Why this matter? Benefits speed, few lines of code, accuracy, correct BERT formatting, compatibility, work exactly with BERT, and efficiently, no need for manual vocab. So one of the mistakes here that some of the developer encounter is forgetting special tokens. Mistake 2 is no padding. Mistake 3 is wrong casing. Mistake 4, building your own vocab unnecessarily. So the sample complete code here is we import the BERT tokenizer files from the transformers. We load the pre-trained tokenizers. We have the sample sentences and tokenize it, print the IDs, and convert first sentence back to tokens. We print the tokens and the vocabulary. So yeah. So the final big picture here, Pretrained tokenizer is just a bridge from the raw human text to tokenizer IDs to model input. With the tokenizer, it can understand text. Tokenizer is like a translator.